Alright students, hello and welcome to Chapter 8, Section 2, Laws of Exponents, Powers and Products. We have two objectives for today. The first objective is to find the power of a power, and the second objective is to find the power of a product. We have two new laws of exponents which we are going to introduce to you here this evening. The first one is a power of a power property. The power of a power property says for all non-zero real numbers x, in all integers m and m, x to the m to the n is equal to x to the m times n. In other words, students, what we're trying to teach here is if you have a power of a power, the rule with your exponents is to multiply. So for example, if you had x to the fifth power squared, that would equal x to the 10th power. Because the power of a power property says if you have a power of a power, you multiply your exponents. Our second property today is a power of a product property. This property says for all non-zero real numbers x and y, in all integers n, x times y raised to the nth power is equal to x to the n times y to the n. So for example, if you had x squared, y cubed, raised to the third power, that would be equal to x to the second cubed and y cubed, which could then be simplified to be x to the sixth, y to the ninth. So that's the power of a product property. It says that if you have a power outside a set of parentheses, you must raise each base inside the parentheses to that power. Alright, now that we've introduced the two new properties, let's go ahead and put them into action with some examples. These examples would be great to write into your notes. The first example is 2 cubed to the fourth power. Now, let's teach this through expansion. 2 cubed to the fourth power means 2 cubed times 2 cubed times 2 cubed times 2 cubed. 2 cubed is 3 2's. So if we look at this just by expansion, how many 2's do we have? Well, as you can see, we have 12 2's. So 2 cubed to the fourth power is actually equal to 2 to the 12th. And if you think back to our last slide, when you have a power of a power, what do you do with your exponents? You multiply. And what's 3 times 4? 12. So 2 cubed to the fourth power is equal to 2 to the 12th power. The second example we have here is 10 cubed squared. So 10 cubed squared, what do we think that's going to be? Well, what do we do when we have a power of a power? We take those exponents and we multiply them. So 10 cubed squared would equal 10 to the sixth power. Right there, we put the power of a power property into action. Alright, let's do two more examples here where we utilize the power of a product property. Here we have xy squared to the third power. When we have a power outside a set of parentheses, we take that power and we raise each base to that exponent. So xy squared cubed, we're going to take that third power and give it to each base. So we're going to have x to the first cubed, and we're going to have y squared cubed. X to the first cubed would simplify to be x to the third. Remember, when we have a power of a power, we multiply our exponents. And y squared cubed would be y to the sixth power. So our answer is x cubed, y to the sixth. Let's do that same thing now with our second example. We have a to the third power times b squared. So we would take a to the third and square it, and we would take b to the first and square it. A to the third squared, power of a power, we multiply. A to the sixth, b to the first squared. 1 times 2 is 2. So, simplifying that would be a to the sixth, b squared. Alright students, we've done a couple examples of each property. Now let's do one example that requires you to put both properties, or in other words both laws, into action. Here we're asking you to simplify n to the third power times 2k squared n to the fourth squared. So to simplify this, we're going to go ahead and first of all use the power of a power property. Or excuse me, we're going to use the power of a product property, meaning we're going to take everything inside the parentheses and raise it to the second power. Each base gets raised to the second power. 2 gets squared, k squared gets squared, and n to the fourth gets squared. We can then simplify those by using the power of a product property. So we can simplify 2 squared to be 4, k squared squared to be k to the fourth, and n to the fourth squared to be n to the eighth. We can then go ahead and simplify that by taking n to the third times n to the eighth. And if you think back to lesson 8.1, when we multiply with like bases, what do we do with our exponents? We add them. So our final answer is 4, k to the fourth, n to the 11th. Once again, the first thing we did was get rid of the parentheses by using the power of a product. Then we used the power of a power. And then the last property we used was our multiplication of monomials property, which says when you have like bases and you're multiplying, you add your exponents. So we have a final answer of 4, k to the fourth, n to the 11th. Alright students, we'll go ahead and move on to our next law of exponents today, and that is the power of -1. Now keep in mind here, these are videos. You can stop them, you can pause them, you can rewind them. So if you feel like we're going too fast for you, please make sure you use the stop and rewind features that we have available to us on this YouTube video. So let's go ahead and look at the next law of exponents, and that's the power of -1. And the power of -1 law is pretty simple. If you have an even power of -1, it's always going to be equal to 1. If you have an odd power of -1, it's always going to be equal to a -1. So for example, if I came up to you and said, hey, what is -1 to the 100th power? Guess what that's going to be equal to? Well, since -1 is raised to an even power, it's going to be equal to 1. If I came up to you and said, what's -1 to the 51st power? You wouldn't have to type into your calculator -1 times -1 times -1 51 times. You could simply just see that you have -1 raised to an odd power, so it's always going to be equal to -1. So that's the power of -1 rule. If you have -1 raised to an even power, it's always going to be equal to +1. If you have -1 raised to an odd power, it's always going to be equal to -1. So some of you guys, this might be your best bet to get a boyfriend or a girlfriend. If you took -1 and raised it to the 1005th power, you might be able to impress somebody. Somebody might say, geez, how do you know that? Well, -1 raised to an odd number is always equal to a -1. Alright, let's go ahead and look at an application problem here. Application problem number 1 says, what is the area of a square if each edge of the square has a length of 6a to the fourth? Well, to find the area of a square, you take one side times the other side. So we'd have 6a to the fourth times 6a to the fourth. Correct? Or in other words, you could do 6a to the fourth squared. So 6a to the fourth times 6a to the fourth, using our knowledge of the laws of exponents, 6 times 6 is 36. a to the fourth times a to the fourth would be a to the 8th. And that's our solution. The second example, what is the area of a rectangle if one side has a length of 12x cubed and the other side has a length of 6x squared? So to find the area of a rectangle, what do you do with your length and width? You go ahead and you multiply them. 12x to the third times 6x squared. 12 times 6, if we go ahead and multiply that out, 12 and 12 is 24, 24 and 24 is 48, and then another 24 would take us there to 72. So we would have 72, and then x to the third times x squared would be x to the 5th power. So we'd have 72x to the 5th power. Alright students, now we want you to try some of these. So try the following 4 problems and then pause the video. And then the next slide on the video will have the answers to the 4 problems. Alright, here's the solutions. Number 1, you should have had 3 to the 10th power. Number 2 should be x to the 6th, y to the 12th. Number 3 should be negative 1. And number 4 should be negative 72, x to the 9th, y to the 15th. Tomorrow in class, we will go ahead and review this information a little bit more, and we'll see if we can't reach a mastery level with it. Thanks for listening. Have a great night.
Made with Doodlecast Pro.